Good morning, students. I am Munsi Rashidul Islam, Assistant Professor of Department of Mechanical Engineering, JIS College of Engineering. Now, today's topic is design of gears. So we have completed almost two modules, and that modules actually the basics of fundamental of design. Mainly that part mainly only based on the theoretical part, and obviously now module number 2 that also all we already covered, and that part is covered by the chapter. That chapter is SAPT and also the different type of VRE. Now today we can discuss about the module number 3, and that module obviously based on the different types of gear. So gear mechanism, gear terminology, all the gear accessories and gear related parts that can be discussed in these classes or ongoing classes. So first of all, we have to know what is gear and how it is used for the transmission of motion or transmission of torque from one point to another point, and what are the law of gearing, and also the different and gear system, gear transmission system. So that means that is actually sometimes we know that uh, gear is termed as a gear drive. Why it is called gear drive? So if I told you that gear drive, that word is most popular because without if I say gear, that is not the meaningful word. But if I say gear drive, so that is a appropriate word. Why it is drive and the gear? So gear means if I say the one simple gear that I manufacture in workshop or any other production unit, so only gear it cannot be work properly. But if another gear is attached to the or another second one, so on that processes the power or torque or in any type of motion, that motion may be linear to linear, linear to transverse, or linear to curvilinear, any type of motion that can be transmitted from the one shaft to another shaft. That is actually the function of gear. So for that's why we can say that the gear is not a appropriate word. Always we can told that gear drive is a proper word. So mainly but one question will arise: why we use gear drive, but any other drives are there, but why we call the gear drive is a perfect or compact drive? But it may be some reason. That reason is, first, it can that means the some advantage is there in gear drives. So number one advantage is uniform motion or uniform power can be transmitted from one shaft to another shaft without any slipping chance. Slipping chance means, suppose if you see that in belt drive, chain drive, rope drive, all the drives that also can transmit power or torque or motion from one shaft to another shaft with the help of any medium. But all the three drives that I say few minutes or few seconds ago, all the drives have a tendency to slipping chance. And slip means something loss. Something loss means time loss, energy loss, everything is loss. So in gear drive, no slipping chance will be there, because power or torque or motion can transmit when the two gears are in contact position. Two gears are in meshing conditions. If the two gears are in mesh conditions, For that cases, only power can be transmitted. And so, what are the advantages of using the gear drives over different types of uh, drives? So, first one, obviously, I told you that number one, it has no slipping chance. Motion and power can transmit without slipping. Number one. Number two, high input speeds. Number three, variable output speeds, high input power, high precision, compactness, and also assembly between the parallel and skew intersecting shaft, and also the high interchangeability, high lever of mechanical efficiency. These are the advantages of using the build drive, sorry, advantages of gear drive over any other drive. Now, next point is what we need to know about gear. That means what I know about the gear. So first point is we know that from gear we know types of gear means how many types of gear are there. Number two, terminologies or nomenclatures. Number three, force transmitted. Number four, design of a gearbox. So these 4 points we can know in this lesson on in these topics. So these are the figure. That figure is actually a empirical figure, pictorial view of a gearbox. That is actually a compound gearbox, and all the housing means all the systems covered by a housing, that is called gear housing. And also there are lot of gears are there, and just minutes, one two three four five gears are there, and mainly three gears, five gears are there, and all the gears are in a compound position. That is the one type of gear train system. Train system means, suppose mainly there are four types of trains in gear. Number one, simple gear train. Simple gear train means when the two gears are in simply face to face meshing conditions, that is called as a simple gear train. Next, compound gear train, when the one gear is attached with a same shaft, but operate in smoothly to other shaft. That is the compound gear train. Next, uh, next, reverted gear train, and last one is epicyclic gear train. Epicyclic gear train is such type of gear train where the gears are there, and with some gear arms also be there. So that type of gear train is called epicyclic gear train. So next point is gear terminology. Gear terminology means, suppose some points are there, that points we can see the what are the defined resources means, suppose some point that can I discuss in the classes of resource point means if we cannot discuss these following points, the gear design or any type of gear design cannot be solved by this gear design process. So that's why that point will be discussed in this class, and we can discuss one by one with empirical or mathematical notation. So first one is module. So firstly one gear can be derived, and one gear can be classified by the module. If I will not say the gear module, we cannot purchase any gear. So gear module and gear diameter must you have to say when you going to purchase a gear. So first of all, what are the definition of module? So module is a ratio of uh, gear diameter to the number of teeth of the gear. So that means module is denoted by a small m, and it is also mathematically diameter means obviously capital D, and total number of teeth, that is actually capital T. So total module definition will be m is equal to d by t. That is actually the definition of module. Next, circular pitch, that means the it is actually a measured along with the pitch circle and circular in the distance between the two similar adjacent point of the teeth, between the two similar adjacent point of the teeth. And that means obviously obviously the teeth will be fully connected with the uh, second number of teeth gear, and that means the total circular pitch definition, that is actually pc. P means pitch, c means circular. Pc is equal to pi d into t. Pi d pi d total periphery of the gear into number of teeth of the gear. Next, addendum. Addendum means, that means a piece circle dia. Piece circle dia, it is actually a imaginary diameter to draw the any pitch circle, any teeth profile. So pitch circle diameter is actually a important point. That point is actually counted in terms of to calculate the different types of teeth profile. So we know that mainly two types of teeth profile are in your syllabus. One is involute teeth profile, another is cycloidal teeth profile. So in any type of teeth profile, we can say that and the full depth teeth profile and the half teeth profile, both are allowed in case of to a drawing a teeth, full speed teeth. So that means, so involute teeth profile and cycloidal teeth profile both are same, but in the shape of the both function are same, but shape of the teeth profile will different. That is actually the teeth profile definition. Next, addendum is actually the imaginary line above the pitch circle diameter. And if I draw a line, if I draw a circle with the center to the addendum and draw a circle, that is called as a addendum circle. And now next point is dedendum. Dedendum is actually below the p circle diameter. Below the p circle diameter means if I see, so suppose one figure is there. Just wait. This line, that is actually the point. That point, that point can I express now. The addendum circle. Here we can see the pitch circle dia. Pitch circle dia means just center line crossing point, and that point is termed as a pitch circle dia. So pitch circle dia, above pitch circle dia, that point is marked as a addendum, and that circle is touched to the above of the pitch, above of the teeth face, above of the teeth face. That means upper portion touching circle will called as a addendum circle, and obviously vice versa of addendum is called dedendum. That means below the below the pitch circle dia, that one imaginary line, one imaginary circle can we can draw, and that line passes through the bottom of the bottom of the teeth profile, and that circle is called as a dedendum circle. And next point is mm tooth thickness. Tooth thickness obviously, and it is actually a thickness of individual teeth, and that is counted on the just below the uh, lower portion of the teeth profile, that is called the tooth thickness. And next point, obviously no points are there. Another point is there, that point is uh, now next point. Suppose now go back to the main slide. No, this slide. Now next is gear ratio. Gear ratio means we know that the one driver gear and another is driven gear. So driver and driven, that's speed ratio, that ratio is called as a gear ratio. And diametral pitch, one point we have left this, that is diametral pitch. It is also termed as a, pd. That means diametral pitch is it is actually just vice versa of the module. A module definition is d by t, but in diametral pitch, it is defined as the ratio of total number of teeth to the diameter of the gear. That is called diametral pitch, and it is also a number. It is also a diametral pitch. It is also 1 by m value. 1 by m value means m means module. That means the inversely proportional of the module. Next, law of gearing. Law of gearing, that means the gearing system, that is actually constant transmission of system transmission of velocity ratio with the two teeth profile. And then that teeth profile, when the two teeth are in connected, in such a cases that the two gears are in connected in a same sequence of the two profile, that profile is connected in such a manner that the pitch point is passing through the point. So so that is actually the law of gearing. When the two missing gears are meshes, that that is actually the point, and that point is actually now law of gearing means when the two gears are in connected means meshes with each other. The top flange is connected to the lowermost portion of the opposite gear, and one side is lowermost portion is connected to the bottom of the gear. So that is actually the point of intersection. That point of intersection where the two gears are in passing through a tangent. That tangent is actually the connecting tangent, and that has some gap. That area have some gap, because if you are not allowed some gap, the two teeth profile are totally compacted, and if the two teeth are in connected, then we cannot separate each other. So that is for that's why we can give some space, or give some clearance to split up the two gears when the engagement system are in over. So that is actually the mechanism of law of gearing. And now this is the figure. This is the so now center one another point is there. Common tangent that I already told you that common tangent, addendum, dedendum, pitch circle, pressure angle. So pressure angle and another point is there, pressure angle and center distance. Pressure angle, that means it is actually an angle, an imaginary angle, which I assume that to draw some certain angle to the teeth profile, to show the teeth profile of the each and every gear. So actually, a Pissar angle is a angle, imaginary angle, which is used to draw a teeth profile. That teeth profile is actually show in the gear or in gearbox. Now, next point is center distance. Center distance, that means the two opposite side gear, center to center distance will be called as a center distance. So one center distance, if suppose one gear diameter is d1 and another gear diameter is d2, so center distance will be d1 plus d2 by 2, because center to center distance, that is the main fundamental point of this point. Now next point is uh, now we can see standard teeth, gear teeth. Standard gear teeth means that the first column is indicate that items, second column that I already told you that mainly two types of angle, so two types of angle will be there, but here three types of angle: 20 degree, 20-degree full depth and 20-degree stub. So 20-degree full depth and 25-degree full depth. So addendum is identified by small a, dedendum, clearance, working depth, hole depth, to thickness and face width. So for first case, 20-degree full depth, so addendum will be 1 by P. Here P is equal to pitch circle dia. So 1 by P. Dedendum 1.25 by P, clearance 0.25 by P, and working depth 2 by P, and hole depth 2.25 by P, and that's all for the similar way. And you can see or you can use this table as a uh, chart of calculating any type of gear problem. So you must follow this chart, and that is actually the standard for all types of gear, spar gear design. Next, gear train. If you can see that gear train, now first one is, that is actually compound gear train. So in compound gear train, here 1 2 3 4 5 gears are there, and 5 gears, all the gears are in separate, mounted on the separate shaft. Only 2 and 3 gears are mounted in same shaft. That's why it is not if we are not calling this as a simple gear train, it is obviously a compound gear train. So compound gear train is called such type of gear when the more than two gears are mounted in one shaft. So that type of gear train is called compound gear train. So So how can I get the gear ratio? So gear ratio can be calculated in terms of so N1, N2, N3, N4, N5. These are the revolution per minute means RPM. So N1, N5 by N1, N5 by N1, N5 by N1 is equal to, so for fast cases, 1 to 2, one gear is connected with the two, so 1 to 2. So gear ratio is gear ratio is same direction. So for that cases, it also be minus. So minus N1 by N2. Next, 3 is connected with 4. So similarly, the second point is N3 by N4, and obviously minus symbol. And last one is 4 will connected with 5. So minus N4 by N5. So N4 cancel, and next point will actually the N1 by N5. That is actually the sorry, N5 by N1. That is actually the of case of compound gear train. Now next point is planetary gear train. Planetary gear train means that is actually epicyclic gear train. Now in this figure, in planetary gear train means it also named as sun and planet gear train. So in a planetary gear train, you can get high torque ratio in smaller space. That means in small space area, you can get maximum torque with small duration or small distance covered by the um, gears. So that is actually the figure. If I see the figure, that figure is one gear, that gear is connected with one point that marked by 1, and another gear is there that is called the planet. So for that reason it is called as sun and planet gear, and both the gears are connected in a arm. That arm is called gear arm, and that arm is known as termed as 2. So and these two gears are inside the one big gear. That gear is called is ring gear. So ring gear is rotate. Ring gear is rotate in clockwise direction. So obviously, planet gear rotate in the same direction, but sun gear will rotate in the opposite direction. So from that cases, we can chalk out a table when the table is calculated to calculate the actually gear ratio or speed ratio, and that is find out by the one tabular form. And this type of problem you can easily solve. Sun and planet gear problem you can easily solve if I apply the two methods. Here the two methods are there. If you see in your subject that you already covered up in most probably fourth semester, that subject name was mechanism. In mechanism subject you have already covered up this part. That part is actually the two methods are there. One is annular method, and another is tabular method. So in tabular method, in this type of problem, that means the sun and planet gear problem, you can easily solve. But in numerical method, numerically, if you can try to solve this type of problem, it is much more difficult, because some calculation will be error, some difficulty will occur. So for that cases, tabular form must you follow, and that tabular form, if you mind it, you can easily solve all type of sun and planet gear problem. So thank you for these classes to attend, and the next classes we can discuss the upcoming syllabus of gear. Thank you.